Okay. All right, so let's think about what we've done so far real quick. We want to kind of put this in perspective so it makes sense what we're doing today. In the past, we've talked about how to factor trinomials. We did that in Module 3. We'll get a little more practice with that this chapter as well. We talked about how to deal with two-term polynomials using patterns, right? But we also said the first thing we always want to try to do is factor out a greatest common factor. That's always our first step whenever we're factoring polynomials, okay? So is there a greatest common factor here?
Yeah, 8.
Eight.
Well, I guess the x3. Yeah.
Okay, so yeah, that kind of messes things up, doesn't it? Because the coefficient of x cubed is 1, and so I can't have a number part of the greatest common factor, right? There's no number that's going to divide into all those numbers other than 1, and that doesn't do us any good. Factoring out a 1 doesn't change anything. How about x's? Is there a power of x I could factor out?
1. Well, 2. Maybe. No.
What do you think? The answer is no. How come?
There's nothing. There's no a. Like there's no.
Okay, because there's no x there, right?
Yeah.
If there were at least one x in each term, then I could factor out a power of x, but there's not. This one doesn't even have an x, so I can't factor out even just a plain old x, right? So there is no greatest common factor, so that part isn't going to help us. So now we got to move on, and we're going to have to deal with this four-term polynomial. So the strategy that we have, this is new, the strategy that we have for factoring a four-term polynomial is factoring by grouping, okay? So when you factor by grouping, here's what you do. We're just going to break it into two groups of 2. So we got the first 2 terms and the second 2 terms, right? You getting this? Okay? First 2 terms, second 2 terms. We want to find the greatest common factor, first of all, of the first 2 terms. So group 1, we'll call that. This is group 1 and this is group 2. So in group 1, what's the greatest common factor?
The x is 1. Well.
There's no number, right?
No.
But what power of x? Now, don't say it out loud. Everybody just think about this for a second. I want everyone to be able to answer this question. This is an important one. What power of x could I factor out of the first group? Now, just think for a second. It's going to be the biggest power that I could divide away from each term. So what's it going to be? X to what power? Squared. Yeah, x squared. Because that's of the 2 powers of x, that's the smaller of the 2, right? Okay, so we can factor out a greatest common factor of x squared. So that's my GCF, right? Okay, what are we left with then? All we have to do to figure out what's left behind, remember, is just divide each term by the greatest common factor. So x cubed over x squared is what? X. So the first term is just going to be an x. Negative 8x squared divided by my greatest common factor, x squared, is what? Negative 8. Okay, so we might call that our leftover factor. That's one way to describe it. Okay, so this that's our leftover factor. Yes?
So do you keep the x squared on the outside? Is that part of the equation?
It is. Yeah, so what we're saying is that these first 2 terms, group 1, if I factor it apart, I get x squared times x minus 8. Now, what would happen if I redistributed the x
It
squared?
would become to the original one, right?
Yeah, I just go to the original one, right? Okay, it's in factored form instead of multiplied out or expanded form. Okay, so then here's what we need to do. In order for factoring by grouping to work, we're going to get this pattern going here. It's all about a pattern. We want to have the same leftover factor in the second group that we have in the first group. That's our goal. I mean, it's either going to work or it's not. And so we're going to do the same stuff that we did to the first factor to the second factor. But to make things a little bit easier, instead of going through that whole process of seeing what the greatest common factor is of these big numbers, that's a little bit hard to do. So instead, let's just assume that this leftover factor is going to work over here as well. Okay, so we're going to say that x minus 8 assume that that's the leftover from group 2. If it's not, this pattern won't work and we just can't factor this thing. If it is though, then we can go further. All right, so the question is, I'm going to put a plus sign in between here because I've really got first group plus second group. Okay, and they're separated by a plus, right? First two go together, second two go together. My question is there a number that I could factor out of the second group that would leave me with x minus 8? We don't know, but we will see, right? In order for it to work for the first term, what would that number have to be? Have to negative 64, right? Does everybody agree that if I want to take negative 64x and divide by something so that I end up getting x left over, that something would have to be a negative 64, wouldn't it? Everybody agree? Right? So then that's what we're going to put out here. Okay, now we just have to see if that's going to work for this other part. Okay, so if let's just see, if I divide the 512, if I take that negative 64 and divide 512 by that, what do I get? Well, if I do that, 512 divided by negative 64 is negative 8, so it does work. Okay, so the pattern worked. Once the pattern works, then now we're going to, and you got to really think about this for a second, we've got group 1 with these two factors. I've got the GCF and the leftover. I've got group 2 with a different GCF, but the same leftover, right? We want to factor out the greatest common factor of each of these two terms, right? So what's that going to be? Honest, what's that going to be? What's the greatest common factor going to be from group 1 and group 2? What do you think? Not sure? Okay. Maybe you got to pay a little closer attention to this. How about? Okay, so anybody else have an idea? 8. It's going to be that whole thing, isn't it? It's going to be the leftover. That's the one that we want to be the same in both of these. So I'm going to take this leftover factor and I'm going to pull that out front. Right? Now, what's going to be left over if I do that? Here's how we can think about this. I'm going to divide that away from each of these two terms. Oops, something like that. So what's left behind if I'm going to take that and I'm going to divide it away from each? Yeah, I'm left with, in the first term, when I divide that away, I'm just left with an x squared, right? Everybody see that? Oops. So that's the contributor, that's what's left behind when I pull this out front from the first term. How about the second group over here? Negative 64, right? If I take this leftover common factor and divide it away, I'm left here with a negative 64, right? Get the idea? Okay, so that's helpful. Okay, another way to think about that would be, all I did was, I'm going to show that. I took each of these, that's going to be too messy. I took each of these groups, each of these terms, and divided by x minus 8 so they canceled, right? I really want to show you that though. I really do. I think that would be helpful. Let me do one thing. I think I can. Okay. What? Where'd it go? It doesn't. I don't know what I just did. Oh well, I guess I can. That's all right. I don't know. Okay, so what did we do then? We took this 4-term polynomial and we've split it apart into 2 smaller, more manageable factors, right? We end up with, and I can rewrite this second one, I get x minus 8 times x squared minus 64, because plus and negative is just subtracting, right? Yes,
So in
ma'am?
all those equations, like, when all these equations, you always add them? Is that why you have the plus up top also?
Well, right here, you mean?
Yeah.
Because really what I did up here on top is I just grouped this. I had this group plus that group, right? Does that make sense? When I draw that line down there, I'm saying I'm going to break it up into a group of 2 terms plus a group of 2 more terms,
Oh, okay.
right?
Yeah.
Okay, so can I go any further with this, right? We know that this one is done. This one is done because it's not taken to any power. If I were to have this set equal to 0, for example, because that's probably why we're doing this. We're trying to solve an equation. If that were equal to 0, what would the solution be that goes with that factor? 8, right? We would just get x equals 8, done. But what about this factor, though? That one's not quite done, right? I mean, if I set this equation equal to 0, I could solve it that way. You're right. But for now, let's look for a pattern. Is there a way that I could take this quadratic, this blue factor, and break it apart again? How many terms are in that blue factor? 2. What's our strategy for factoring 2-term polynomials? No? Remember we did a bunch of that day before yesterday, and the day before that? Oh, okay, good. So we're trying to find a pattern, right? We're trying to find a pattern. It's got to be a sum or difference pattern. Either a sum of cubes or a difference of cubes, or a sum of squares or a difference of squares. Which one of those patterns could possibly fit this
The
one?
difference is squared.
Yeah, because I've got x squared minus something, right? So it's the difference of squares pattern is the one that we want to maybe potentially use here, right? So the difference of squares pattern, remember, is just this one. If we have a squared minus b squared, we can split that up into what?
A plus B and then A minus B.
Yeah, a plus b and a minus b, right? So what's our a and what's our b?
X
Can we
is-
write this as something squared minus something squared?
X.
X, and then what squared is 64?
8.
8, okay. So x is like my a, and 8 is like my b, right? And that's, I could think of that x squared minus 64 as being x squared minus 8 squared, right? And so at x minus 8, we'll leave that out front because it's already done. But by our difference of squares pattern, what am I going to get there? If x is a and 8 is b, what's that going to break up into?
X plus 8 and then X minus 8.
Yeah. Right? Now we can't go any further, can we? Right? That's done because now each one of those is broken down up into a linear factor. The x's aren't being squared, right? There's one last thing we could maybe do to just write this in a simpler way. How else could I do this? I've got x minus 8 times x plus 8 times x minus 8. If I multiply in a different order, maybe it'll make more sense. X minus 8 times x minus 8 times x plus 8. Well, what's x minus 8 times x minus 8?
So it's squared.
Squared, right? If I multiply something by itself, I'm squaring it. So I could write this as x minus 8 squared times x plus 8, okay? And that's the fully factored form. That's the original function written in factored form. Okay, now why might that be useful? There's a bunch of reasons that might be useful. One of them is, we could make a sketch of this thing, right? So let's take this opportunity and let's just quickly review how we could crank out a quick sketch of that function. What are the x-intercepts going to be? Yeah, this one's going to give me an x-intercept of 8, right? If I set it equal to 0 and solve, and that one's going to give me negative 8, right? So, okay, so if I were to graph this thing, if I were to sketch it, so let's just say that that point is out here at x equals 8, and this is at x equals negative 8. I've got x-intercepts. at both of those places. Is there anything unique about this x-intercept? What happens, the fact that it's being squared, what does that do?
It just touches the x-axis but doesn't go through it.
Okay, it's gonna bounce, isn't it, right? It's not gonna go right through. This one's gonna go right through because it's not being taken any power, right? So at -8, I know I'm just cutting right through the x-axis, but this one's gonna bounce. Now, what about end behavior? If I were to multiply this out, either here or up here, I would have gotten x times x times x is x cubed, right? Good, x cubed. And it would have been a positive x cubed. In fact, it would have been that. If I multiplied the whole thing out, that's what I'm going to get, isn't it? Right? Would you agree that's a third degree polynomial? That's odd, isn't it? Right? It's an odd polynomial. What's the end behavior for an odd polynomial? Are the ends the same or different?
It is different.
They're different, right? Regular end behavior would be this one, right? Where it's going to go up on the right and down on the left. That's why you're working when I do that. But that, you get the idea? Even behavior would be like this. Odd would be like this, right? Okay? So then, if I multiply by -1, what would that do to my odd behavior?
That's gonna flip it.
I would flip it like this, right? If it were even, that's normal. If I multiply by a negative number, it's going to flip it, right? Okay, so we know then that this one is normal. It's odd and it's not multiplied by a negative. So that means to the right, it must go up, and to the left, it must go down, right? How could I do this then? If this is the one that's bouncing and it has to go up, isn't it going to end up being like this? That's the only way I could draw this thing, isn't it? Because it's got to go cut through the x-axis at -8, straight through the x-axis at -8. It's got to go down on the left end. It's got to bounce at +8 and go up at the right end, right? We don't even need the table, do we? See that? Okay, so it is important to be able to get it in this form. All right, let's try another one of those. How about this one? Okay, what do I want to try to do first?
Group it.
Okay, I'm going to group it, but first I want to see if I can factor out a greatest common factor. Is there a power of x I could factor out?
No.
There is not. Is there a number?
No.
Not really. And how would we know? Let's kind of think about just the number sense part of this. If you look, for example, at 25, that's only got, what are the possible factors of 25? 5 or 1 or 25, right? Well, 25 or 5 could not possibly divide into those numbers because they don't end in 5 or 0. You see that? So there's no way it could work, is there? Right? There's no way. So we can't factor anything out. So we've just got to break this into groups. So talk me through this then. If we break this thing into groups, what do I do with group 1?
Divide by x squared.
Okay, so I'm going to factor out an x squared. Is there anything else I could factor out? And we would have to probably just have a calculator and see. But
4.
4 would work. How about anything bigger? Does 8 work?
Yeah.
Yep. How about 16?
Sure.
Yeah.
Yeah, 16 works. I think 16 times
5. No.
8. 16 times 8 is 128. So we could factor out a 16x squared. Now what's that going to leave us with? Okay, so then if we divide each of those by the greatest common factor, we'll see what's left over, right? So what is x cubed divided by x squared? That's going to be an x. Good. So we know we're going to get an x, and then 128 divided by 16 is 8, right? How about -16x squared divided by 16x squared? -1, right? Because everything's going to cancel, right? So I just get a -1. So that's my leftover factor. So now let's look over in group 2. How am I going to see if group 2 factors the same way? In fact, if I can group it. Okay, I'm going to see if that's going to work, right? I'm going to assume that it's the same leftover factor and just see if I can make that work. Well, if it's the same leftover factor, what would have to be out front? So I've got to ask myself, -200x divided by what is going to give me +8x?
-8. Well, no.
So what's that going to be? So -200 equals 8 times what? Well, I could just divide negative 200 by 8 and find out. What would it be?
It's
25?
Yeah, it's
Okay. So it's gonna be negative, it's gonna work out to be negative 25, right? And all I'd have to do to find out is just say, once again, I could just say negative 200x divided by 8x equals negative 25, right? Okay, so it worked. If I divide negative 200x by negative 25, I get negative 8x. Well, what is 25 divided by negative 25?
Negative 1.
So it worked, didn't it? See what I'm saying? The other way to check that would just be to go ahead and distribute. If I take the negative 25x and I distribute it to both terms, I better get that. If I do, it worked, right? Does that make sense? Okay. All right, so it did group. We were able to factor by grouping. So now what? What do I factor, what do I pull away from each group? What do I factor out of each group? 8x minus 1. Good. There's my common factor, isn't it? Right? So if I divide each of these terms by 8x minus 1, what happens? So that's my greatest common factor. Okay, look what happens. The 8x minus 1s cancel, don't they? Right? Okay, Brent, let's figure that. Okay, does that make sense? So what's left over? So what's left over? What's going to be the leftover from this group over here?
16x squared.
Okay, plus, what's going to be, Maisie, what's the leftover from this group? If I divided away that 8x minus 1, what's left behind? Negative 25, good, okay. And so there we go, right? We got it down to something much easier. So we took this big ugly polynomial and we broke it apart into a product of two smaller ones. So this is the blue one, we could more simply write as just 16x squared minus 25. What's the possible pattern that could work there? I've got two terms. Which one could possibly work? It's got two terms, so it's got to be a sum or difference pattern if it's going to factor. What do you think?
Squared. Like,
Is it going to be a squared minus, or a squared plus b squared, or a cubed minus b cubed? What's the one that could fit? Cubed?
no, it'd be a squared minus b squared.
A squared minus b squared. So the question is, could we take this blue factor and could we write it as something squared minus something squared?
Yes.
Well, what squared is going to turn into a 16 times x squared?
8x.
No?
No, 4x.
4x, there you go. Because if I distributed the power of 2 to the 4, I'd get a 16, right? What squared is 25? Okay, so then I've got this is already done, my 8x minus 1 out front, but now I can break this apart because it's a difference of squares pattern, isn't it, right? So we get 8x minus 1 times, what's that going to break apart into? A squared minus b squared breaks into,
4.
well, so, yeah, a which is 4x, plus b times a minus b, right? Does that make sense?
Yeah.
Okay, and we're done. That's it, as far as we can go.
How would you do the end behavior on that stuff?
Okay, so if we wanted to figure out, if we wanted to sketch this thing, the end behavior, well, look at the original. What's the degree of that?
3.
3. Is the 128 positive or negative?
Positive.
Positive.
Oh,
So it
should be the
hasn't been
exact same
flipped.
thing.
Yeah, so it'd be like that, right? Only we'd have 3 x-intercepts. These would be weird x-intercepts. What would this one be? Can anybody tell me? If I set that equal to 0 and solve, what would I get?
Negative.
I'd get negative,
7.
let's see. So if I set that equal to 0, I would add the 1 to this side, right?
X
And then divide by 8, right? So one of them would be at 1/8. where would this one be? Imagine it's equal to 0. I gotta subtract the 5 over and then divide by 4. So I get negative 5/4. And this one would be at
Why would you get
positive 5/4,
Why
right?
would you get fractions and so confused?
Well, you could. That just means the x-intercepts don't fall at nice convenient spots. Those are the x values where the function would cross the x-axis. Okay. But we don't have to graph this one. That's okay. I mean, that's I just did that last time so you could kind of get a sense of why it might be important to do this, right? But that's the answer Moodle's looking for. Okay. One more. One more of these. This one could be a little quicker, right? So there's no greatest common factor, right? Everybody agree?
Yeah.
Okay, so we'll split this thing into two groups. First group, what's the greatest common factor?
X squared.
X,
Cubed. Sorry.
x cubed, okay. So there's my GCF. Whatever goes here, would you agree that whatever goes there is also gonna go there?
Yeah.
Okay, we can already start thinking ahead a little bit, right? Those go together. So what is left behind? If I divide,
X minus 3.
yeah, if I divide both by x cubed, I'm just gonna get x, right? X to the 4th over x cubed is x. 3x cubed over x cubed is 3, so I get x minus 3. So I'll push that over there and just see if we can make it work. Well, what times x would make negative 64x? Negative 64, right? See what I'm saying? So does that work over here though? Negative 64 times negative 3, does that give me 192?
Yes.
It does. Okay, it does, so it worked, right? All right, so then what's gonna be my greatest common factor from each group? What's the common? I've got two factors in each group, right? In group 1, I've got x cubed times the quantity x minus 3. In group 2, I've got negative 64 times the quantity x minus 3. Which one is common to both?
X minus 3.
X minus 3. So I can factor out my common factor. And what I'm left with then is what?
X cubed minus 64.
There you go. Okay, good. Okay, so can we go any further? So I got
X
two-term pattern. Which one could this maybe
X
fit?
cubed minus X cubed.
Okay, that could fit difference of cubes, a cubed minus b cubed, right? So let's look at the a cubed minus b cubed pattern. So how does that work? If I have, oh, I'm not gonna have room there. Right here. So if we have a cubed minus b cubed, what's the little factor that we get from that pattern? That's a minus.
A minus B.
Okay,
and
the
then
big
A
factor?
squared plus
Good,
AB
plus.
minus B squared.
No,
Plus
plus.
B squared.
There you go, plus b squared. So then, can we write this, let's see if we can write ours as something cubed minus something cubed. So this is like my a and that's like my b. What's the a gonna be? What cubed is x cubed?
4.
I mean, negative.
4.
Well, that one's just x, right? But this one is gonna be, yeah, it's a 4. 4 cubed is 64, right? So now we just follow our pattern. So the blue, this blue factor here is gonna break up into a minus b times a squared plus ab plus b squared. So a is x, b is 4.
X minus 4.
Okay, what's a squared gonna be?
X squared.
X squared
Um,
plus
4.
a times b
4x.
plus b squared,
Which is 4 squared.
so 16. Okay, so then we get, when all that dust is settled there then, this has broken up into those two factors, right? X cubed minus 64 is the same as x cubed minus 4 cubed, and it broke up into x minus 4 times x squared plus 4x plus 16, and don't forget out front the x minus 3. Okay, so that's it. We're done. Right? Can't, now, one last question. Could we go further with this?
Yeah.
Yeah.
No, remember we can't.
Oh.
We can't. It's,
Oh,
whenever
so
you
when
do
you're
those
done.
patterns, right, when you do the factoring patterns, the big factor in difference of cubes or sum of cubes is always gonna be done. It's always gonna be an irreducible quadratic and you can't go any further. So you don't even have to think about it, you're done, okay? Make sense? Okay, go down and grab let's see if there's enough of them. Let's grab a Chromebook. See if you can do at least one of these problems. It's on your homework, so you're actually doing your homework. Follow me.
I don't wanna get up.
You go there.
What? You actually
You got yourself some time and now you're teaching much.
Yeah, we'll see.
That was useless.
What do you do when you're
Where'd Greg go?
Okay, so grab Chromebook and go to the 6.4 practice number 2 and try to do at least one problem from that first group. I want to make sure everybody can. Go ahead.
Which one?